Howdy, and welcome to the Texas A&M 12th Astronaut Lab. Our project this year is to scout augmented reality visor design. Our team leads are as follows. Our advisors are Dr. Anna Diaz, Dr. Gregory Chamadoff, and Mr. Darren Welsh.
The UI compass interacts with its pointer to display the location of a point of interest, such as a rover or a lander, in relation to the EV crew member. The text above the pointer displays the name of the object and the distance to it. The points rotate to indicate the appropriate direction of the waypoints. As seen in the video, the user is selecting waypoints from the navigation menu to display on the compass. These markers can be set by the EVA or IVA crew members before and during the spacewalk. This compass serves to provide a sense of spatial awareness in bare environments such as the moon.
The Scout AR Assistant main menu is a quick access interface accompanied by buttons that toggle specialized panels detailed later. In case of view obstruction, there's an option to either hide it or change its size. Its panels can follow the user, be placed in space, or attached to a flat surface via a toggle button. The panels can be scaled or angled to fit a field of view for certain operations. In addition, they are transparent for better visibility. For better controls, voice commands can be initiated with a "Hey Scout" call phrase. There are commands for opening or closing panels, hiding or showing the main menu, and speech-to-text input. Seen in the first video is the astronaut interacting with the Umbilical Interface Assembly, or UIA. The astronaut is seen iterating through the procedure on the UI task panel and flipping the switches indicated. The switch holograms overlaid on the UIA panel animate which switches need to be flipped and shows their correct position. Seen in the second video are the interactable box and arrow holograms. These holograms can be placed based on the procedure or by the remote user to indicate position or highlight certain items. For example, this video shows the user dragging the appropriate hologram off the UI panel and placing him into the view of the astronaut. These holograms can be manipulated and placed to indicate specific areas to assist the astronaut.
The Lunarpedia note-taking system is used to create, store, and recall entry logs. The user can create an entry, add a picture and description using the voice logs, and store its location as a spatial anchor, as shown in the top photo. The Scout Assistant takes care of real-time voice transcription using the Azure Cognitive Services framework. Once the user saves the log, it is saved as an object in the Azure Blob Storage resource. The user can also display and edit any previously created log and location, and the photo and description will be updated in the cloud storage, shown in the bottom photo. The Scout AR program has integrated Azure Custom Vision machine learning for object detection of various items required during extravehicular activities, including the umbilical interface assembly, tools required for science sampling, and examples of good lunar samples. From the Science User Interface panel, the astronaut can start a scan of the area around them. The photos taken from the scan are sent to the Azure Custom Vision resource server and are returned with the tag identifying the items detected, the probability of each item being correct, and the location within the image of the item. And the HoloLens spatial map is used to place the tooltip in the appropriate location within the field of view. In the photos, the data from the camera scans recognized a photo of a rock sample and a UIA and appropriately tagged them in real time.
This is the AR Telepresence Whiteboard. The video on the left shows the view from the HoloLens 2 EV crew member. The video on the right shows the view from the remote user, which could be mission control or an IV crew member. The two users can converse in real time and maintain situational awareness using the textured spatial mesh scan from the headset replicated across the network. Using the Photon server, the remote user can spawn holograms and use the spline pen to draw in the EV crew member's field of view.
There are three design aspects that can be improved on: our internet reliance, our environmental considerations, and our usability considerations. Our program relies heavily on Microsoft's Azure services for many of our features, such as our voice-to-text functionality, and as such, the lack of internet can lead to an almost unusable program. We can solve this by using more of the HoloLens onboard storage and sensors and creating an offline mode. When considering the environment, we realize that an abundance or absence of light can cause the HoloLens to get lost and lose UI functionality. To counter this, we plan to implement a dimmed visor on the sensors. Lastly, it would be beneficial to create an onboard interactive tutorial for the user before fully utilizing our program.
Thank you from all of us for watching our presentation about our project and our team. Do you have any questions for us? You can find us on social media platforms with the tag @TamuNASASuits, or at our website, 12thastronaut.com, or through email at 12astronautteam@gmail.com. This way you can find more updates and more information about us. Thanks and gig 'em!